Imagine sinking through 29 kilometers of solid ice on Europa, Jupiter's frozen moon. No light, no sound. Just the weight of a frozen world pressing down on you from every direction. And then, after what feels like an eternity of darkness, the ice gives way. You break through into open water, but this is not any ocean you have ever known. There is no sky above you, no surface to swim toward, just a ceiling of ice stretching in every direction, sealing you inside a body of water that has never seen a single ray of sunlight. And the terrifying part is not the darkness. It is the growing suspicion that you might not be alone. Europa does not look like a threat. From a distance, it looks almost peaceful. A pale, icy marble streaked with reddish-brown lines, like veins running beneath frozen skin. It is slightly smaller than our own moon, just over 3,100 kilometers across. It orbits Jupiter once every 3.5 days, locked in a gravitational embrace so tight that the same face always points toward the gas giant. On the surface, it is one of the smoothest objects in the entire solar system. Almost no craters, no mountains, just ice, cracked and scarred, but eerily flat. And that smoothness is the first clue that something strange is happening beneath. On most moons and planets, craters pile up over billions of years. Europa barely has any. That means the surface is being constantly replaced. Something from below is pushing upward, erasing the old scars and laying down fresh ice. The most widely accepted explanation is simple and unsettling. Europa has an ocean, a global liquid saltwater ocean, hidden beneath kilometers of frozen crust. And it has been churning quietly in the dark for possibly billions of years. The first real hints came from NASA's Galileo spacecraft, which orbited Jupiter from 1995 to 2003. During its 11 flybys of Europa, Galileo's magnetometer detected an induced magnetic field, not from within the core, but from something electrically conductive beneath the surface. The best explanation was salty liquid water. Then came the images. The cracks on Europa's surface form massive intersecting patterns called lineae, some stretching hundreds of kilometers, consistent with the surface flexing and splitting apart over a liquid layer. Some regions showed chaos terrain, areas where the ice appears to have broken apart, shifted, and refrozen in a completely different arrangement, like a jigsaw puzzle that was shaken and put back together wrong. That kind of disruption only makes sense if something warm and fluid was pushing up from below. But how can liquid water exist so far from the sun? At roughly 670 million kilometers away, the surface temperature hovers around negative 160 degrees Celsius. Everything should be frozen solid, and it would be if not for Jupiter. Europa is caught in a gravitational tug-of-war between Jupiter and its neighboring moons, Io and Ganymede. Their combined influence keeps Europa's orbit slightly elliptical, and that changing distance creates tidal forces. Jupiter's gravity physically stretches and compresses Europa's interior with every orbit. That constant kneading generates heat through a process called tidal heating. Think of it like bending a paperclip back and forth. The metal gets warm at the point where it flexes. Now imagine that happening on a planetary scale, continuously for 4.5 billion years. The ocean is enormous. Current estimates suggest it could be around 100 kilometers deep. The deepest point in Earth's oceans reaches about 11 kilometers. Europa's ocean could hold 2 to 3 times the volume of all water on Earth. And all of it is locked away in complete darkness, beneath a frozen lid. In January 2025, NASA published results from the Juno spacecraft's 2022 flyby. Using its microwave radiometer, Juno measured the temperature profile of Europa's ice and settled a debate that had raged for decades. The ice shell averages about 29 kilometers thick. That is roughly 18 miles of solid, rigid, frozen water between the surface and the ocean. Juno confirmed the thick ice model, and that carries a heavy implication. A thick ice shell means the ocean is deeply isolated. Europa's surface is blasted by Jupiter's radiation, which splits water molecules and generates reactive chemicals. If those chemicals could seep through the ice and reach the ocean, they could potentially fuel life. But 29 kilometers is a formidable barrier. Juno detected small cracks and pores in the near surface, but they only extended a few hundred meters down, nowhere close to reaching the ocean. And yet, there are signs that the ocean is not completely cut off. In 2012, the Hubble Space Telescope captured images of what appeared to be enormous plumes of water vapor erupting from Europa's south polar region, rising as high as 200 kilometers above the surface. Then, in 2018, researchers went back to old Galileo data and found something remarkable. During a 1997 flyby that brought the spacecraft within 206 kilometers of the surface, the magnetometer recorded a shift of more than 200 nanoteslas over just 3 minutes, while the plasma wave spectrometer detected a sharp spike in plasma density. The only model that matched was one where Galileo had flown directly through a water vapor plume. The evidence had been sitting in the data for over 20 years. If those plumes are real, the ocean is actively venting its contents into space. Europa is not just frozen, it is breathing. And that means a spacecraft could fly through one of those plumes and sample the ocean directly. No drilling through kilometers of ice, no landing on a surface that would destroy most electronics within hours. Just a flyby through a cloud of ocean spray. That brings us to the radiation. Europa sits deep inside Jupiter's magnetosphere. At the surface, the radiation dose is equivalent to about 5.4 sieverts per day. A single sievert causes radiation sickness. 5 in a day would be fatal. The radiation also destroys any organic material on the surface. If biosignatures were brought up by geological activity, Jupiter's charged particles would shred them. In the highest radiation zones near the equator, you would need to dig 10 to 20 centimeters below the surface to find material that has not been chemically altered. So, could something survive in that ocean? We do not know, but the ingredients are disturbingly promising. Life requires liquid water, chemical energy, and the right elements. Europa has the water, possibly more than Earth. It likely has the elements. The question mark hangs over the energy. On Earth, life thrives in places that resemble what we imagine Europa's ocean floor to be. Along mid-ocean ridges, hydrothermal vents pump superheated, mineral-rich water into the freezing darkness. Entire ecosystems live there, completely independent of sunlight. Bacteria feed on chemical energy, converting hydrogen sulfide into food. Those bacteria support worms, crabs, shrimp, and fish. Life that has never seen the sun. But in 2024, studies suggested that Europa's rocky interior may not produce enough heat to drive volcanic activity on the seafloor. Simulations showed that magma likely cannot travel through the thick rock above it to reach the ocean floor. Without active volcanoes, a major source of chemical energy disappears. There is a counterpoint, however. A process called serpentinization can generate chemical energy at much lower temperatures. When seawater percolates into cracks in rock and reacts with certain minerals, it produces hydrogen gas and heat. A 2016 NASA study found that Europa's ocean could maintain an Earth-like chemical balance through serpentinization alone. And simulations from 2024 showed that low-temperature hydrothermal systems on ocean moons could persist for billions of years, long enough for life to emerge. The James Webb Space Telescope confirmed carbon dioxide on Europa's surface in 2023, specifically in Terra Regio, an area of chaos terrain. The carbon dioxide appeared to originate from the interior, suggesting the ocean itself contains carbon compounds. Webb also confirmed the water vapor plumes. Europa was not just leaking, it was actively releasing the contents of its hidden ocean. On October 14, 2024, NASA launched Europa Clipper aboard a SpaceX Falcon Heavy rocket. It carries 9 scientific instruments designed to map Europa's surface, measure its ice shell, detect organic molecules, and confirm the subsurface ocean. The spacecraft will arrive at Jupiter in April 2030 and perform 49 close flybys, swooping as close as 25 kilometers from the surface. If plumes are active, Clipper's mass spectrometers could sample them directly, tasting the ocean without ever touching the ice. The answer, whatever it turns out to be, is frightening either way. If Europa's ocean is barren, it tells us something deeply uncomfortable about how rare life might be. But if something is there, even a single-celled organism feeding on chemical energy in the dark, it changes everything. It means life is not a fluke. And if it happened twice in one solar system, the universe is not empty at all. Europa does not care about our questions. It just keeps orbiting, keeps flexing, keeps hiding its ocean beneath 29 kilometers of ancient ice. Whatever is down there has been waiting in the dark for longer than complex life has existed on Earth. And right now, a spacecraft is hurtling toward it, carrying the instruments that might finally let us listen. Thanks for watching, and I'll see you in the next one.